I want you to take your foldable and not fold it in half, but fold it corner to corner and only crease the very top part of it, because that gives us a place to fold in the sides and fold in the sides. I need you to take your scissors and cut this way to the fold, but only so where you can read that when you open it, and cut on this side this way to the fold, but only so you can read that on this side. Very good. So let's open up this top left-hand corner section. Let's do this section first. The imaginary unit I is defined as I equals the square root of -1. Because here's the deal. Mathematicians and scientists were solving quadratics, kind of like we're doing now, but probably a little harder, okay? And they were getting negative roots, and they had to stop because they don't know what to do. But these weren't just like random problems they were making up. They were like real mathematical problems, okay? Square roots of negative numbers are showing up in all sorts of different real world type of problems, so we needed something to represent the square root of -1 so I could keep going, so I could figure out what was going in the problem, okay? A lot of times these show up, I know specifically in the study of space, like outer space, right? Do I, as a math teacher, do I really need to know where Jupiter is in 5 years? No. But if I'm designing a spacecraft and trying to send a spacecraft or a satellite to Jupiter, do I need to know where Jupiter's going to be in 5 years? Yeah. And the problem was like they couldn't because -1s were coming up or negative numbers were coming up underneath the roots. Okay. So they were able to develop this whole new section of mathematics called that studies complex numbers, which we'll get to in just a second, but it has to do with the imaginary, okay, imaginary parts, because we had negatives underneath the roots. So first of all, what do we do with them when we get them? Well, remember when we talked about square rooting numbers to begin with? We could just straight up take the square root if I knew it, but if I didn't, I could separate it into parts. I could say this is -1 times 4. Would you agree with that? And remember, the rules of radicals say then I can go straight here. Square root of -1 times the square root of 4. Well, do you know the square root of 4? Yeah, that's 2. Did you know the square root of -1 before today? No. But now you know the square root of -1 is I. So this answer then is 2I. Now earlier they said, why didn't you put a plus or minus? Well, remember, who put the root sign in the problem? Did I? No, it was already there, right? If it's already there, the answer is 2I. If it said square root of 4, what's the answer? 2. Because I didn't put the root sign in the problem, it was already there. If I put the root sign, I have to remember the plus or minus. Okay? So what about the square root of -45? How can I break that down? -1 times 9 times 5, which can be broken into square root of -1 times the square root of 9 times the square root of 5. What is the square root of -1?
2I.
The square root of -1 is I. What's the square root of 9? 3. And what's the square root of 5? Yeah, I don't know either. Right? So I just get 3I root 5. I need you to be careful about something though. The square root of -2 does not equal the negative square root of 2. Where the negative sign is matters. Do I care about this negative? Oh, yes, because it's inside of the root. That's going to give me an I. Is this negative going to give me an I? No. Okay? Okay so far? All right. Okay. Let's go to this circle. I drew it this way on purpose. Okay? I just told you that I is the same as the square root of -1, right? So what does I squared equal? What is the square root of -1 times the square root of -1? Right? That's going to come into play here in just a second. Okay? Well, then what's I to the third power? Isn't that just I squared times I? So isn't it just -1 times the square root of -1? So it could equal -1 times the square root of -1. But we said the square root of -1 is I. So I could say this is the same as -I. I cubed can either be negative square root of -1, depending on what you need, or it could be -I. Well, what about I to the fourth? How can we rewrite I to the fourth? We could write it as I cubed times I, but couldn't I also write it as I squared times I squared? Well, what's -1 times -1? 1. Now, there's a reason that it's a circle, okay? Because I to the fifth is the same as I to the fourth times I, right? What's 1 times itself? Excuse me, what's 1 times anything? Just that anything, right? So isn't this I to the fifth also? Then what's I to the sixth? The same as I squared. What's I to the seventh? The same thing as I to the third. What's I to the eighth? Same thing as I to the fourth. Here's what I mean. I could ask you on a quiz or test, what's I to the 25th? And you should be able to tell me. One way you could do it is like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And you know that I to the 25th is the same as I. Okay? Or you could think of the fact that I to the fourth, that's like the end of, even though it's a circle, that was the last one we did on the circle, right? So every time I come around, this is the I to the fourth, right? So this is also I to the 8th, and also I to the 16th, and also I to the 20th, right? So I could figure out the number if it's divisible by 4. If it's divisible by 4, it's the same as this, right? But if it's not divisible by 4, we could just go around the circle till we get to that. So if I'm asking for I to the 25th, is 25 divided by 4 divisible by 4? No, but 24 is, right? That means this would be I to the 24th, which means this would be I to the 25th. And so I to the 25th would be the same as I. Isn't that what we said just a minute ago also? But wasn't that faster than going 1, 2, 3, 4, 5, right? Because here's the deal. I might ask you, what is I to the 100th? You really want to sit here and count to 100 going around the circle? What is I to the 100th? Well, is 100 divisible by 4? Yes. That means I to the 100th is 1. Then what is the I to the 103rd? Well, 100 is the closest number divisible by 1. So this would be 101, 102, 103. So I to the 103 would be -I. Does that make sense? Close that. Go down to complex numbers. Complex numbers and graphing complex numbers. Let's give a definition to complex numbers. Okay? Complex numbers are written in the form A plus BI, where A is the real part of the number and B is, what do you think? Imaginary. BI is the imaginary part of the number. We can graph complex numbers. We don't graph it on a regular real number plane like we normally graph numbers. We would have to graph it on a complex number plane. On a complex plane, we don't have an x-axis and a y-axis. We have a real axis and an imaginary axis. Real is here, imaginary is here. So if I was plotting the point 2 plus 3i, I would go 2 on the real axis and 3i on the imaginary axis. So that is where the point 2 plus 3i would be. Does that make sense? Well, if it does, then tell me how to plot the number 3. So just go right 3. Tell me how to plot the number 2i. Up 2 on the imaginary axis. Tell me how to plot the number 2 minus 2i. So right 2, down 2. Tell me how to plot the number negative 1 minus 3i. So right there. Any questions about that? Do you feel confident in graphing complex numbers? Okay, let's close that section. Now let's talk about adding, subtracting, and multiplying complex numbers. Like normal, adding and subtracting are just kind of together, right? When we're adding and subtracting, all we're doing is combining like terms. Real plus real, imaginary plus imaginary. Can we add real and imaginary? No. The only time, there's two, but I think you guys will only know one. The only time that I know that you can add real and imaginary, the only time that it's worked, Space Jam. The other one that I know is Who Framed Roger Rabbit, but I don't know if you know that movie. Just know that it worked. Okay? So if we're doing this, then real and real, 2 and 3. Does anybody know what 2 plus 3? Oh, 5. Okay, good. 5. And then imaginary and imaginary, 5i and negative 2i. So plus 3i. You okay with that? What about this next example? This is subtraction, right? Sometimes you guys struggle with subtraction because you forget to subtract. What did we decide last time we should do?
Subtract. Wow.
Distribute a negative 1 right there. So what we have is 4 minus 3i minus 2 plus 5i. Do you remember us talking about that?
Yes.
So then I have 4 and negative 2. 2. And then I have negative 3i and plus 5i. Okay so far? How confident do you feel in adding and subtracting? 100%. That's nice. Excellent. Let's talk about multiplication. Okay? So does it make sense that we would use distributive property? Now, the instructions are almost always going to be simplify, or they might say simplify completely. Either way, it's not simplified completely if I has an exponent. I cannot have i's with exponent if I want to simplify it completely. So if I distribute this, what do I end up with? Negative 20i squared. Except what? What did we just decide I squared was the same as? Negative 1. This number is actually negative 1. So I actually have negative 20 times negative 1. It's just 20. What do I do in a problem like this? Distribute. So what's 2 times 3? What's 2 times negative 5i? What's 3i times 3? That's 9i. God bless you. And what's 3i times negative 5i? God bless you. Negative 15 I squared, right? So I've got imaginary and imaginary that I can combine together, but I also have this. And what is that the same as? Negative 1. So I have negative 15 and negative 1 times negative 1. What does that equal? Well, what's 15 and 6? 21. And then what's negative 10i plus 9i? Negative I or negative 1i, right? How do you feel about that? Pretty good? Okay. Ready to close it? Okay, let's close it. And we'll go on to the last section. Have I ever used this word with you guys before? Yeah, last week, right? Last week we talked about radical conjugates, right? Today we're talking about complex conjugates. I want to remind you, first of all, that A plus BI and A minus BI are complex conjugates. You could have probably figured that out if I gave you enough time, but we're trying to get through our foldable, right? So I'm just reminding you, how do we find complex conjugates? What do I do with the real part? Leave it, right? I leave it. What do I do with the imaginary part? They are opposites, right? BI and negative BI. So let's make sure that we understand how to get complex conjugates before we have to use them. Okay? First of all, the sum is a real number and the product is a real number. Okay? We can talk about that later if you need to. That's just like part of the definition. All right? 8 plus 5i is the number we're talking about. What is its conjugate? Eight minus 5i. 4 minus 3i is the number we're talking about. What is its conjugate? 4 plus 3i. Remind me again how we get a conjugate? We just take the opposite? Be more specific. Opposite of the imaginary part. The real part stays the same, right? So if I tell you the number is 6, what is its complex conjugate? 6. Now, before we do this last one, I need you to know, well, you don't need to know, I'm just telling you. This is my favorite imaginary number. It was my nickname growing up.
4i?
What is the conjugate?
Oh.
Negative 4i.
4i.
Okay. Yeah, I wear glasses. You guys know that, right? I wear glasses. Well, I wear contacts every day, but now I also have to wear reading glasses to read. It's awesome.
Muy fun.
I love getting old. Okay. Now, the reason we had to talk about complex conjugates is because we have to divide complex numbers. I cannot leave an I in the denominator. The way that I get i's out of the denominator to simplify a complex number, I multiply by 1. Well, that seems like it's not going to do any good, right, if I multiply by 1? But if you'll remember, when we simplified radical denominators, it didn't just look like the number 1, did it? It looked like something divided by itself, right? The something that divided by itself that we're going to use is the conjugate of the denominator divided by the conjugate of the denominator. That's why I showed you how to find a conjugate first, so now we can use it. Okay? So for that is, yeah, absolutely, that's 1, right? And that's what I have to do, is I have to multiply it by 1, and this is the value of 1 that I'm going to choose. Okay? So if I do this first example, I have to notice, first of all, that there's an I in the denominator. Okay? When I notice that, then I say, what is the conjugate of the denominator? Negative 3i. And I multiply the numerator by 3i and the denominator by 3i. Sorry, negative 3i. Does that make sense?
Yes.
Well, what do I get in the numerator if I multiply it by negative 3i? Very good. What do I get in the denominator if I multiply it by negative 3i? Negative 9i squared. And what did we decide that this equals? Negative 1. So then I end up with negative 21i over 9. Because negative 9 times negative 1 is 9. Is that all the way simplified? It is not. What are they both divisible by? And if I divide out a 3, what do I have left? Negative 7i over 3. Very good. Okay? Now, some people mistakenly think, oh, I see. Okay, so you just flip it over and change the sign and move the I. No. Can I show you that that's not going to work? Let's do this example right here. Okay? I notice there's an I in the denominator, so I decide that my conjugate is what? 2 plus I. So 2 plus I over 2 plus I. Okay, so now I'm distributing. 6 times 2, 12. 6 times I. 6i. 4i times 2. And 4i times I. 4i squared. 2 times 2. 4. 2 times I. Good. Negative I times 2. And negative I times I. Negative I squared. Okay? So let's start in the numerator. If I'm starting in the numerator, I'm noticing a couple things. First of all, I've got 2 imaginary terms I can combine, but I also have this. What does that equal? Negative 1. So I have negative 1 times 4, which is negative 4, and negative 4 and 12. What does that equal? 8. Okay, now what's 6i and 8i? 14i. All right, in the denominator, first of all, I have this, and what's that? Negative 1. And then second of all, I have this. And what's this? 2i and negative 2i? That's 0. And that's why we use conjugates. Because that is always going to happen. The I terms are going to go away. They're going to be opposites. And they're going to go to 0. So I have a negative 1, which is 1, and 4. 5. Any questions? What's the last thing we need to be able to do to be able to use this? Please put your name on the back.